Hi everyone, welcome to today's session of tips and tricks from Summit for Max. Sure, it's going to be an interesting one. For much more, subscribe to the channel and press the bell icon for further notifications. Let's get started. Today we are going to learn how to calculate the number of triangles in a given figure. Let us divide this topic into 5 different types. Here in type 1, we are going to count triangles in squares, rectangles and quadrilaterals. In this square, we have 4 blocks of triangles. So, the number of triangles into number of diagonals will give you the total number of triangles. So we have 2 diagonals. So 4 into 2 will give you 8. The total number of triangles here is 8. Here we have 8 blocks of triangles in this figure. And we have 2 diagonals. So 8 into 2 will give you 16 triangles. So the number of possible triangles here is 16. In the next figure, here each square has 8 triangles. The combined square has 2 triangles, one on either side. So 8 plus 8. Here are the 2 triangles. Can you visualize? So 2. So 8 plus 2 plus 8 will give you 18 triangles. Here in the last figure, each square have 8 triangles and the combined square will have 2 in the first pair and 2 in the second pair. So totally we'll have 28 triangles. Hope you can visualize it. So here we have 28 triangles altogether. Here in type 2, counting triangles with the triangle having number of bisects with vertex. So here in the first type we have just one triangle. Here in the second type the number of possible triangles is 3. If the number of bisects keeps increasing, we can calculate it with a formula. Here check for the number of vertical paths. So we have 4 paths. Use the formula n into n plus 1 by 2. So 4 vertical paths. So n is equal to 4 into 5 divided by 2 will give you 10. In this type we have 5 vertical paths. So the number of possible triangles is 5 into 6 divided by 2, which will give you 15. Isn't that interesting? So we can calculate for any number of bisects with vertex using this formula n into n plus 1 by 2. Here in type 3, we are going to learn how to count triangles within a triangle having a number of bisects with the vertex and horizontal lines. In the first diagram, we can see 2 triangles. So here in the second triangle, let us take the vertical paths as n and horizontal paths as m. So we will get 6 parts altogether. Use this formula n into n plus 1 by 2 the whole into m, where n is the vertical part and m is the horizontal part. In the third diagram we have 4 vertical parts, so n is equal to 4 and m is 3 horizontal part, so m is equal to 3. So using this formula we can calculate the number of triangles in this diagram as 13. Here we have 5 vertical parts and 3 horizontal parts. So 5 into 6 divided by 2 into 3 will give you 45 triangles. So the number of possible triangles here is 45. In type 4, we are going to count triangles within embedded triangles. So here is a triangle and we have one embedded triangle. So n is equal to 1. Here we are going to use the formula 4n plus 1. So n is equal to 1 means the number of triangles here is 5. Hope you can visualize it. Here we have 2 embedded triangles within the main triangle. So n is equal to 2 and the total number of triangles will be 4 into 2 plus 1, which is equal to 9. Here in this triangle we have 3 embedded triangles, so n is equal to 3. So the total number of possible triangles is 13. In type 5, we have to count the triangles within a particular pattern of triangle. So here the formula we are going to use is n into n plus 2 into 2n plus 1 by 8, where n is the number of unit triangles in one side. So here we have 3 unit triangles. So 3 into 5 into 7 divided by 8, which will give you 13.12. So that can be rounded into 13. So in this type of triangle we have 13 possible triangles. Here in the second one we have 4 unit triangles in the side. So n is equal to 4. So 4 into 6 into 9 divided by 8, which will give you 27. So we can get 27 possible triangles from this pattern. Hope this session was interesting. For much more, let us meet next week on tips and tricks. Thank you.